At late 20th century, somewhere around mid-80s, when world was not ready to accept much changes, suddenly CAD steps into the market and everywhere boom was exploding. Level 0 explains about the 2D drawings, most likely as CAD, just manually drawn lines and handwritten details of the project or building. Each and every project participants create their own 3D intelligent model, which contains information in it, where if you just click on the wall for example, it will show you all the details of it from dimension to the volume and the area. AEC stands for Architect, Engineers and Construction Industry. But most important question is, what is BIM? There was a time when BIM was not an option for construction developers. People were using traditional approaches at that time. तो ये traditional approaches क्या थी? Architects, structural engineers or MEP experts were creating their own drawings by manually hand-drafted methods. Though it was time-taking and contains lots of error in it, which not only responsible for creating delays, but also lots of hard work required for the same. At late 20th century, somewhere around mid-80s, when world was not ready to accept much changes, suddenly CAD steps into the market and everywhere boom was exploding. CAD ने जैसे पूरे मार्केट में रिवॉल्यूशन ला दिया, which was the reason for creating new jobs, mindsets and some easiness in the construction industry. But does CAD have fulfilled all the demands of the AEC industry requires? Absolutely not. Major reason was it is limited to 2D only, which again creates problem in the better visionary and minor details of the project. Still today, many companies are using CAD files or 2D drawings as a main tool for their construction practices. I don't say it is wrong, but as I mentioned earlier, it is time-taking and increasing the chances of the errors. Somewhere nearly at 2012, BIM was introduced into the AEC market. AEC stands for Architect, Engineers and Construction Industry. But most important question is, what is BIM? Building Information Modeling. For some, it is a process. For some, it is a software. For some, it's a database. Or for some, it's just a 3D model. So, आपकी नज़र में BIM क्या है? Kindly comment down below. BIM is not only limited to 3D modeling or for some softwares. BIM is an intelligent 3D model-based process that gives architects, engineers, and construction professionals the insights and the tools to more efficiently plan, design, construct, and manage the buildings and infrastructures of the society. Major difference between the CAD and BIM is CAD helps people to draw, where BIM helps people to design, construct, and manage throughout the project. So आइए BIM को और डेप्थ में समझते हैं. There are multiple levels in the BIM, like level 0, 1, 2, and up to 3. There are chances that in future it may be increased. Level 0 explains about the 2D drawings, most likely as CAD, just manually drawn lines and handwritten details of the project or building. Level 1 talks about the mixture of 2D drawings and 3D models. Majorly these models does not contains any information in it. It is only for visionary purposes. For example, Google SketchUp model. If you click at any element in the model, it will not provide you any details regarding the element. Where level 2, each and every project participants create their own 3D intelligent model, which contains information in it. Where if you just click on the wall for example, it will show you all the details of it from dimension to the volume and the area. But something was lacking, that there is no central beam model in the collaboration, just like Revit architect structure or MEP models, but as a separate files rather than having fully collaboration between them. Due to this lacking, even though there are intelligent models, still chances of the errors are there. Hence comes the most advanced option in the BIM is level 3, which is also known as I-BIM. I stands for the interoperated data. For some people, I stands for intelligence also. No matter. In I-BIM, a central beam model is created which combines input from every project participant. For instance, an architect creating a wall into a central beam model and a structural engineer creating footing for it. Suddenly, architect realized it is in the wrong position and decided to change the location of the wall. Immediately, a message will pops up to the structural engineer screens that location of the element has been changed. Wow means each stakeholder will be notified if there will be any change in the main project file. That means if something has been changed, it will be recorded that what has been changed by whom and when. This level is most likely to reduce the errors and saves the time. But this is not the thing where BIM ends. This collaborative approach requires something, and that is CDE. CDE means Common Data Environment. It is an most important part of a BIM management. CDE combines all the stakeholders of the respected project and serves them the latest error-free information and details in the segregated format. There will be multiple revisions in the drawings due to multiple reasons. But how would a project coordinator or a manager or a design coordinator will know about the latest revision? And how would they know what is the revision about and whom to coordinate it with? Maybe to the architect, to the structural team, site team, landscape architect, MEP experts, or with the client. For how long? Maybe throughout the project? Oh my god, this challenges. But no worries, CDE plays an important role to manage and segregate the data from all the stakeholders. For example, BIM 360 or Procore, where you need to link your intelligent 3D collaborative model, and as per the comments from the stakeholders, it will be notified to the respected team who will be responsible for the development of that part of the building or the project. They will update their part and be free within no time. Hence, the other team members will get a notification about the updation in the drawing or the 3D model of the project. So, from the traditional approaches to the latest advanced technology, BIM has plenty of the things to share and to create revolutionary impact to the world. In today's world, BIM reaches the sky with the latest technology like artificial intelligence, blockchain, machine learning, and lot more.
Dimension is a something which allows us to refer the things in a better way. For instance, a circular point. This is the best example for a 1D or a one-dimensional data because it is showing visually graphical details which is in one dimension, as like this address shown here, showcasing location of the point. This dimension represents individual elements within the model. It includes basic information such as the location, coordinates, and identification numbers. Suppose if I add lines around the point, this will be my two-dimensional details of the project. This includes the floor plans, elevations, and sections, providing a clear visual representation of the building in x-axis and y-axis. Most of the stakeholders even today work in a two-dimensional only. It is a very less accurate method for the visualization of the project details. It is mostly depends on the draftsman ability and visualization capacity. Then comes the volume. Here where the things get exciting. Three-dimensional data is generally known as the volumetric data, which possesses details in x-axis, y-axis, and z-axis. This 3D brings depth into the model, allowing stakeholders to visualize the entire structure in three-dimensional data. This includes not only the building itself, but also the elements like the furniture, fixtures, equipments, and many more, as far as you visualize and see in the real-life detailing. This three-dimensional data creates much more clarity among the stakeholder for design, construction, and operational works. How? We will see in the seventh dimension. For now, this data helps to visualize problem at early stage to resolve it immediately rather than facing problem on site where you have very less possibility to change anything in design or construction manner wise. Up till now, things are really normal because majority people knowing this much about the BIM. But if we add one more layer to it, it will become the fourth dimension, which is also known as time. Time adds another layer of the complexity by introducing the element of scheduling and sequencing. 4D beams enable projects manager to visualize the construction timeline, anticipate potential delays, and optimize the resources accordingly. For instance, a contracting firm has lots of projects to deliver at a time, where 4D beam helps them to visualize each day progression as per the resources and equipment allocation to the particular project. They clearly able to see the completion date of the project accordingly. So they better plan manpower, equipments, and material requirements before the projects actually get started. Now comes the 5D, which is the money matters. That means overall cost of the project. 5D beams incorporate cost data into the model, providing insights into the financial aspect of the project. This includes material quantities, labor cost, and overall budget management. Here BIM engineers do delay analysis, earned value analysis, and plan versus actual cost data analysis. This will clearly state the actual data of the project and indicates to the firm about the spending analysis on day-to-day basis of the project. This definitely brings much more clarity to the stakeholders that what to use and what not to use in next upcoming projects. Then comes the sustainability, which is the sixth dimension. Sustainability is increasingly important in modern construction. And why it's so? It integrates environmental data, energy efficiency measures, and life cycle analysis, enabling stakeholders to take informed decisions that minimize the project's ecological footprints. For example, carbon analysis. To encourage the stakeholders, go for eco-friendly materials and for a lean construction. Then comes the energy consumptions or a daylight or a lightning analysis to reduce the use of the artificial resources and brings nature to the light. Once all the designing, construction, and quality checks work will be completed by the stakeholders, then comes the handover part, where all the data from the different stakeholders will be submitted to the client or owner of that particular structure. Here comes the seventh dimension of the BIM, known as the facility management, which truly focuses on the details like what have been purchased by whom. In simple words, the vendor details. That billing part of the procurement department, which focus on the operational phase of the building's life cycle. This dimension includes maintenance schedules, equipment manuals, and other crucial information for the facility managers to efficiently maintain the building in a post-construction phase without any frustrations. And why it is needed? Suppose a door frame has been bought by XYZ vendor and this is fully get defected in a period of 1 year. What will owner do? Owner will check the details of the vendor provided like warranty period of that frame, from where it has been bought and which company it is belongs to. This detail will be registered in the 3D intelligent model, so no paper or researchable digital data has to store anywhere in your locker or in your computer. That is integrated in 3D intelligent model itself. This is the power of building information modeling. That all data is digitally available on your fingertips.
Is revolutionizing the construction industry. But what really makes a BIM model valuable?
It's the level of the detail and the accuracy that goes into it. And that's where the LOD comes in. If we talk about the LOD, what does it basically mean? Level of a development or a level of a detailing? And there are other concepts also like the level of the information. Let's dive into the LOD first. At LOD 100, the model includes basic geometry shapes and the placeholders. Think of it as the rough sketch, stage perfect for a conceptual design when you are just getting your ideas onto the paper. When you are just started with the design, you will not draw the things as they are. Simply putting a box at a place of a table and wrapper it or mark it as a table will be the best example of it. You can do it to the multiple elements with the multiple intent, simply drawing some shapes and wrapper them as per your data, as you want to show a basic conceptual understanding of a design among various stakeholders. Moving on to the LOD 200, you start adding more detail specific product representation and approximate quantities. It's ideal for a schematic design phases when you are deciding on a dimension and a spacing of a particular object. Here if a table needs to put, the dimension like a height, width and length is required for putting a table into the model or a design, which essentially gives an idea to stakeholders how much space is occupied and how good it looks like. By LOD 300, things started to get exciting because the model is started to filled with the soul. What I mean is, with accurate representation of a building components and specific dimension with detailing of their material and texture, this level is crucial during the design development for detailed coordination and analysis. Here where you actually can tell about the specification of a table, like it's a wooden table or a glass one with the metal supports, timber supports or the plastic one. Initially, it is required to better understand the purpose behind the objects and the elements into the design. Once you choose specific material for a desired dimension as per the design requirements, here we talk about the detail connection and the joints about the element. We are going to talk about the LOD 350. LOD 350 contains the connection details, joint details and stability detail within the model. Table example will not be relevant here because mostly it is not a part of a construction. It's a carpenter job to make one and give it to the contractor as per the requirement. Still it requires the connection details somewhat. However, let's talk about the construction details. If structural engineer needs to build detailed design oriented model, they will definitely define the connection details of their elements for the design load calculations. Elements like beam to column or beam to slab connections, these details later on give stability to a model with the proof that design is safe with particular types of the connections. Let's say stitch connection, for example, after the analyzing the whole design. So from the design development perspective, in LOD 350, a structural engineer will say, connections are good to go. Architect will check for the detailing and the connection among their design. Similarly, the landscape architect, the facade architect will check their design. And the MEPF engineer do the same with the design of the ducts, electrical wire, plumbing pipelines and the fire safety pipelines. Once the design development stage covered, the construction model begins to play a crucial role. All this detailing and collaboration are going on into the BIM parallelly from the LOD stage 100, means from the conceptual design itself. At the stage of the LOD 400, a construction model will be developed. To execute the construction activities and installation process of the construction element with more down to the fabrication details. With LOD 350, once you complete with the decision of a connection among various joints, you will need a guidance to install or construct element into reality. with the numbers of the resource like the manpowers, machineries, material, money and time, and with the installation process with the fabrication details, you actually can make it possible. Here we can take an example of a precast element. Suppose a design is fully developed and element casted as per the required design. But if you are not aware of the installation process, you will end up putting your element into the wrong place with the wrong decision and need to bear the cost of the element. Similarly, there are multiple things in the cast-in side or precast construction going on with the contractor side. To avoid such clashes or wastage of money and resources, we need to model up to the LOD 400 as a BIM expert. Once the real-life construction begins, there are multiple chances to the constructions that it do not happen as per the BIM LOD 400 model due to some site constraint or maybe any other reason. Construction activity may differ from the actual LOD 400 model or the information given in it. These changes need to be modeled back into our original BIM construction model. The process of remodeling as per the actual site scenario is known as the LOD 500 or as-built modeling. This LOD contains overall detailing after the construction has been started to the completion stage, that what changes have been made and why. This LOD 500 later on used in the maintenance and operational management throughout the life cycle of the building. This overall concept is known as the LOD in most of the standards of the BIM. LOD means the level of the development of the model as per the particular detailing required into the construction site. LOI simply says while each stage of the LOD, the level of the non-graphical details required is known as the LOI or the level of the information.
I'm here to introduce you to FDM Global, your premier partner in building information modeling solutions. At FDM Global, we don't just create structures, we sculpt dreams into reality. Our team of dedicated professionals works tirelessly to bring your vision to life using cutting-edge BIM technology that sets us apart from the rest. From the moment you step into our office, you'll feel the energy and passion that drives us forward. Our dynamic animations of BIM models showcase the intricate details we put into every project, ensuring precision and excellence at every stage. Witness our experts in action, seamlessly navigating through BIM software to craft masterpieces that exceed expectations. But don't just take our word for it. Our satisfied clients speak volumes about the quality of our work. Their testimonials echo the seamless experience and exceptional results they've achieved with FDM Global by their side. We take pride in delivering end-to-end BIM solutions that not only meet but exceed your needs, ensuring your project's success from start to finish. So, if you're looking for a BIM service provider that combines expertise, client satisfaction, and advanced technology in one sleek package, look no further than FDM Global. Contact us today and let's turn your vision into reality. FDM Global, where innovation meets excellence.